Hello, this is Mr. Miller. Welcome to video 3H, more fun with the quotient rule. To be honest, what can you have but fun with the quotient rule? Fun is guaranteed. All right, let's do it. Okay, so we're going to use the quotient rule to find the derivative of the following trig functions. We know the derivative for sine and cosine. Now that we have the quotient rule, we can find the derivative for tangent and secant as well. And we're going to have to remember these rules. So whatever we come up with, we're going to use many times in the future. So y equals tangent of x, I can rewrite this as sine of x divided by cosine of x. Now I can take the derivative because we know the derivatives of sine and cosine, and we know the quotient rule. Here it goes. So the quotient rule is over here, and the numerator has four things we have to fill in. G, F, F prime, and G prime. We have to put them in here. So here we go. Remember that F refers to the numerator and G refers to the function in the denominator. So the first thing we need is G of x in the numerator. That would be cosine of x. All right, that's going to be multiplied by F prime. The derivative of sine of x is cosine x, so we get another cosine of x, minus F, which is sine of x, times G prime, the derivative of cosine of x, which is minus the sine of x. All divided by G of x squared. So cosine of x squared. All right, well, let's do some simplification. Cosine times cosine is cosine squared x, minus sine times minus sine is plus sine squared of x. And that's divided by cosine of x squared. Now, it's time for that whole year of pre-calc to pay off. Cosine squared plus sine squared is equal to 1 for every value of x. That's an identity from trig. And we have cosine of x squared. Now, we can simplify this a little bit. 1 over cosine is secant. So 1 over cosine squared is secant squared. Because I can think of this as 1 over cosine times 1 over cosine, which is secant times secant, which is secant squared of x. We get y prime equals secant squared. So the derivative of tangent is secant squared. All right, now let's do secant. Secant we can write as 1 over cosine of x. So 1 is f, and cosine of x is g in the quotient rule. So we get y prime equals, all right, g times f prime. Cosine x times f prime would be 0 minus f times g prime, 1, times g prime is minus sine of x, all divided by g squared. So we get cosine squared in the denominator again. Okay, now cosine x times 0 is just 0. We have minus 1 times minus sine x is just sine of x over cosine of x squared. And we're going to do a little trick here. We're going to write this as 1 over cosine of x times sine of x over cosine of x. I just split this up. So everything's still there. 1 times sine is sine. Cosine times cosine is cosine squared. And we get the final result. 1 over cosine of x is secant of x times sine over cosine is tangent of x. So y prime is secant of x times tangent of x. Okay, so we're going to go ahead and apply these. We're going to use these rules. So we're going to take the derivatives of these following functions. They're both products. So we're going to need the product rule. All right, so this is our first function. We'll call this one f times the second function. This is g. So we got to use the product rule here. So we just got to fill it in. Y prime equals f prime times g. F prime would be the derivative of this polynomial, which is 2x, times g, which is tangent x. All right, plus f which is that polynomial, times g prime, the derivative of tangent. We just did that. That is secant squared x. And to be honest, we could distribute the secant squared, but it's not really going to help a lot. It's not going to get any nicer. I'm just going to leave it like that. All right, let's do the next one. I'm going to consider the 7 times x as the first function. That's f times secant of x. That's g. So when we use the product rule, y prime is going to be f prime times g. The derivative of 7x is just 7 times g plus f, which is 7x, times g prime. Derivative of secant we just derived is secant x times tangent x. All right, I'm going to leave it like that. Okay, there's not much we can do with it. I could get rid of the parentheses. We really don't need all those. So 7 times secant of x plus 7x secant of x tangent of x. It's a little bit nicer. I put the parentheses just to emphasize what I was doing with the product rule. All right, here we go. Time to up our game. We're going to do quotients now using our new trig functions. Up here, I have the derivative of tangent, which we derived, the derivative of secant, which we derived, but I also have these two other ones here also, the derivative of cotangent and cosecant. So they're derived in the same way, and we can use these when we need them. All right, so here we go. We're going to use the quotient rule for this. The numerator is f, the denominator is g. Here we go. Y prime equals, we got all this in the numerator, g of x, that's x, times f prime of x, the derivative of cotangent, according to the table, is minus cosecant squared of x, minus f of x, cotangent, times g prime, the derivative of x is 1. All divided by g squared, which would be x squared. So there's not much I can do. I can write this as minus x cosecant squared x minus cotangent x divided by x squared. We can't cancel an x because it's not a factor of this term. Remember, if we divide by x, we have to divide everything by x. We're done. All right. I got 2 more examples for you, so hang in there. This one's going to be a little bit interesting. This time we have x in the numerator and a trig function in the denominator. Okay, well, here we go. Y prime equals, this is f, this is g. So quotient rule says g of x, secant of x, times f prime, which is 1, minus f, which is x, times g prime. Derivative of secant is secant x tangent x divided by the derivative squared, or sorry, the denominator squared, secant of x squared. Now, there's a secant, a factor of secant in every term. Okay, so we can divide everything by secant. So I'm going to write it as factoring out just to show all of my work. We can write this as secant of x times 1 minus x tangent x, because that's what's left here, divided by secant squared, or x squared. And now I'm going to cancel it. I'm going to cancel this. That cancels one of those. And we're left with 1 minus x tangent of x over secant of x. Who knows what the graph of that looks like? We'd need a computer to draw that for us, but that's what we get. That's the derivative. All right, now we came to our very last example. I always want to kind of keep going back to this because this is a fundamental problem in calculus. The problem of finding a tangent line to the curve at a point. That's just not going to go away for a while, so we have to be able to do that. So Actually, here we have a graph of it. This kind of orangish line is, orangish red line is actually the derivative of, or sorry, the graph of tangent. And this right here is the point we're talking about, pi over 4 comma 1. And the blue line is the tangent. So that came out really poorly. So the blue line is the tangent line we're looking for. Okay, so we need the slope of the line. That's the derivative at the point. So the slope of our tangent line is equal to y prime evaluated at pi over 4, the derivative of the function evaluated here. Well, first we got to find the derivative. Okay, so y equals tangent of x means that y prime, well, that's one of our rules, is secant squared of x. So we need that at pi over 4. Well, that'd be secant squared pi over 4. And now, actually, we should be able to do this by hand, but I'm more worried about the derivative now. You can actually find this on your TI-89. You press second, then the button with the math, then you go to the trig menu, and you can find secant there. So secant of pi over 4 is square root of 2, and we're squaring it, we just get 2. So secant squared of pi over 4 is 2. Okay, so that's our value of m. So m equals 2. Now we can just use point slope form. Y minus y1 equals m times x minus x1. So we get y minus 1 equals the slope times x minus pi over 4. And I'm okay with you leaving it like that. All right, now the strategy for finding the equation of tangent line, because this could be really confusing, is first find the derivative. Second, evaluate it at the point. And third, use it in point slope form. Okay, got some problems for you. So you got all the tools you need here. We have the derivatives of the trigonometric functions, we have the product rule, and we have the quotient rule. So you'll need those things. So first, find the derivative of y equals x cosecant x. You need the product rule. Second, find y prime for y equals secant of x over x. That's actually a reciprocal of the one we just did. So it's going to be a little bit different than the example, but just use the quotient rule. Then, find an equation for the tangent line to y equals cotangent x at the point 3 pi over 4 comma 1. You'll probably, at some point, need to look up cosecant on your TI-89 to do that. All right, you guys are awesome. See you in class.